You gotta duck to get in, and then once you get in, you gotta duck again.
This must be what early NASA engineers felt like.
I think it would be best if we drive around a little bit, get some good heat in here. Pretty stiff chassis.
Sure is. Especially for the 80s and 90s. Yeah. See how lean it is when it's cold?
Oh, wow. Yeah. That must have been what he was talking about. What sort of things did you have to do one day? Shrubbery?
So Texas.
No. I haven't seen a shrubbery in the middle of the road in years, and then a mountain F40. Maybe a little freeway, just rolling up and down the freeway.
Sure.
If I saw me or not, so.
Better
You
safe.
feel how sticky the throttle is? Like, I'm trying to feather in right now.
Oh yeah. That's terrible.
It's impossible to be smooth.
got to be a bizarre sight. As if this car doesn't already tend to get attention. Yeah, that's rough.
Yeah, I mean, it's, you know, that's a smooth. In fact, it seems like the smoother you try to be, the worse it is.
Yeah.
You know.
Yeah, that's really harsh.
Oh, you know what? I didn't try. Let me see if it's in neutral. See? It's a little bit easier to be smooth when you're. See, for some reason. So, like, that's like 10 pounds of pressure that I have to put on there. That's like 3. It's way worse when it's in here.
Okay.
So it's almost like vacuum is holding it.
That is a bit annoying when you start really like doing, like when you really have to drive like that, isn't it?
Right.
Up on the highway where you're up in the throttle, it's not so bad, but like that right.
No, once you've cracked open the throttle, it's not sticky anymore. I mean, it's a little heavy, but it's not sticky at all. It's
That's what-
just when you have your foot off the pedal and you go to get back on, it's real
Yeah.
sticky.
That's why I'm wondering if it's not the grease being washed out of the linkage under the plenum from, you know, the car being washed for a few years and it just naturally washed the grease out, because it's that rest position when it's closed.
Right.
You know, I mean, the pivots could have kind of a flat spot right there. See how far off the two sides are?
Right. So about 9, 10, and they're wide open.
Yeah. Yeah, and 10 flat is basically the lower limit of engine combustion.
Yeah, I was gonna say, so it's a little bit rich under boost.
Yeah.
But idle or normal driving actually seems to be okay.
Yep. Yeah, that side was good. While you were under throttle, it was at 10.5, 10.8. But right when you snap it off, it rolls into a 10, which is not surprising because, you know, you're going to have that momentary of load up. I mean, it's even more lean now.
What's that?
It's even leaner now.
Oh, yeah. Wow.
This is the coolest 308 they ever made.
Wow, 112 per second. That's totally crazy. Yeah, so now it's actually running. God, if that's right, that's a little scary lean, actually, isn't it?
Yep.
Okay. So this bank,
Needs a little more.
yeah,
That
you know,
needs-
and of course we don't, you know, I don't know if there's any, you know, what the calibration is like, you know, or are you pretty sure that that's okay? So at least that side needs a little bit of.
Yeah, I mean, we probably got a little reversion going on because like I said 16.5 is the lean limit for an engine to actually really run. So that side might be, you know, if that's accurate, then that side's like dead basically as far as fuel mixture goes.
Yeah.
You know what I mean?
Right. That's like lean. That's a little. It's funny that Waylon was like, oh, they run too rich at idle, and that's what'll come. Like, we're on the opposite end. Like, we need to. It's almost like somebody's messed with this, but I don't think anybody's messed with this. So.
No, like I say, it happens over time, you
Right.
know. I mean, nothing stays perfect forever.
And I will say that the whole dynamics of the ECU work. So, like, the fact that we're running a 20 right now, and we saw a 9 under boost, that's a pretty,
Yep.
you know.
Yeah, the ECU's calculating.
Yeah, and I mean it's cool that the injectors are able to do that, you know, because like
Yeah.
I don't know. Anyways,
Yeah, absolutely.
yeah, it's kind of neat.
Yeah.
The small, teeny little pulses that the injector has to do
Milliseconds.
to do that, right? And then like dumping all that fuel when we're under boost, like
It's pretty trick.
yeah, no, it's pretty awesome. I mean, I know for modern cars it isn't, you know, but anyway, for something designed in 1986, you know.
Absolutely. Yeah. Yeah, it is.
Yeah. All right. Let me help you get out.
It's no joke. Glenn was saying, you know, we're sitting here idling, and this bank's reading about a 20 now that it's nice and hot, and that side's like a 15-ish, plus or minus.
20 at idle?
Yeah.
Ooh.
And but under full acceleration, this side would pull as rich as a 9.8 or so,
Holy cow.
10.0, and that side would stay more like a 10.5 to a 10.7. So it's kind of wild how
That's
swinging dynamic.
quite a bit.
It is.
Yeah, and that's what I'm saying. I know modern cars with the great ECUs, they can handle like really large injectors really well. I'm just surprised that this thing runs as well as it does with technology from the mid 80s. You know?
Yeah.
The drivability is actually pretty good.
Yeah.
Surprisingly, considering
Yeah.
the mixtures, the drivability is actually pretty good. The only drivability problem we have is the throttle cable that sticks. He started to gripe and bitch at me because, you try to put your foot into it and it just
snaps.
You have to put like 10 or 15 pounds of pressure on the pedal, and then it's.
Ooh.
On the highway, when he's in it and rolling in and out of it, it's totally fine. But yeah, as soon as you come off to do a full off pedal decel and you go to step on it again, it's like a light switch,
Oh, yeah. Got the binary pedal, on or off.
Yeah,
A random kind of interesting piece of history, right, is the venerable Pectel engine management systems, right? The great race car Pectel. The original Pectel was based off from this Morelli. So Weber Morelli developed this platform as a motorsport ECU, right, and then put them in the 288s and the F40s, and the versions also went into the Kazi Fords and the Lancia Deltas and stuff, but the Pectel picked up this platform, and that's what they built their system off of.
Oh, wow. Yeah, that's pretty covered in soot.
You made a mess out of my tools, man. Why'd you do that? Why would you do that, Glenn? Well, that's our 9.8, 10.0 AFR right there.
Yeah.
All over.
Yeah, I don't even think we need a computer to tell us it's running a little rich.
No, the taste test will confirm. Tastes like 116.
Well, it's lead-free at least, so.
I'll grab a little flathead screwdriver and we'll plug the little guy back in and
All right, so we're actually going to tune it a little. That's
pump
cool.
it up. So we're just going full nerd, right? Talking about how bitchin' this Morelli Weber injection is for the 80s on this car, but then conversely how much more dynamic and complex a modern engine management system is. So we're talking specifically about the 458, right? Where you have direct injection, which like a diesel now means instead of the injector being up in the intake, it's right in the middle of the combustion chamber next to the spark plug, right? And they now have coils on plug, whereas we were talking about this one has one coil per 2 cylinders. 8-cylinder motor, 4 coils, right? Plus now the 458 has what they call an ionization module where they can actually measure the electric pulse through the spark plug because the density of the fuel mixture changes the firing rate and strength, right?
And
the time and all of that, for the spark plug to fire. So they can actually measure how efficiently the spark plug is firing, calculate how dense the fuel mixture is in the combustion chamber, and within milliseconds change the ignition timing for that one cylinder times 8 cylinders, or in an F12, 12 cylinders, right?
The Scud has an ionization ignition, so they switched it to that.
Yep.
But it's still not direct injection.
Correct.
So it's like halfway to the 458.
Yeah.
But that's how they get it to be a lot more accurate, a lot more versatile.
Yeah, that's one of the reasons why the Scud and especially the 458, they run what used to be race car compression ratios, right? That's a 12.5 to 1 compression ratio on a pump gas motor with catalytic converters, because the direct injection allows greater atomization and finer control of the fuel in each cylinder. And then you've got the ionization in the ignition module so they can control that ignition pulse so much more fine. So that's why you get a 4.5 liter, 9,000 RPM, 600 horsepower V8 that runs through catalytic converters, clean as a whistle out the tailpipe, 7 years worth of manufacturer powertrain warranty.
Yeah.
You didn't get any warranty with this car. You bought it, and however it rolled off the showroom floor, the first bill's on you, bro.
Yeah. Good luck.
So the other side of that is like we're talking on the F40, right? It's got 8 throttle butterflies, 2 throttle position sensors, right? So this is literally 2 individual throttle cylinders
Yep.
join at the crankshaft. So you've got 2 4-cylinder street bikes with a turbocharger running side by side. And you have to balance all 8 cylinders, just like we did with the carburation. You have to balance all the cylinders to each other, and then you got to balance the 2 banks of the engine together to get it to all do the few things that it does harmoniously. Whereas in your car, there's no balancing nothing, man.
Yeah.
It's electronic throttles, like we talked, everything. The computer calculates all of this within milliseconds and makes micro little adjustments and keeps itself. And it's so sensitive. They say in the manuals, anytime you replace any engine management components, you need to reset the learned adaptations and let it relearn. And so once, just out of curiosity, when I did a service, all I did was, fluids, filters, and spark plugs. Fired it up, went down the street, and the first 3 times I rolled on the throttle, it popped and snorted and misfired out the intake until it could recalculate and readjust the ignition timing for those cylinders for the new spark plugs. Now this is on a 20,000 mile 458, not a 100,000 mile Mercedes, AMG. That's how truly sensitive it is the computer runs such tight parameters, it knew the difference between new spark plugs and old spark plugs.
Wow.
Now after 3 rolls on the throttle,
You probably read.
it adjusted itself, but I just had to see, because sometimes they, the manufacturers tell you to do these things, but there's such coarse adjustments and adaptations, you've got a lot of fudge error, But on the 4, I'm like, I just want to know for sure. There you go. There it is.
Wow.
This car's running an air-fuel ratio anywhere from 20 to 9.8, and you can't tell the difference driving down the road. It just goes. The 458, you put a different spark plug in it, and it wants to misfire.
Be crazy is I wonder if they had put modern ignition and modern components on this, how crazy this thing would have been. Because you remember the Competizione, that had over 1,000 horsepower, right?
750.
750, yeah.
Yeah.
Which, what is that? Like a 2.9, right?
Yeah.
2.9 liter engine in the 80s.
It's 50% more power than the standard car.
Yeah, that's insanity.
Yeah, our friend John put a Motec on his because same thing. Now, if you wanted to, a lot of that's done for preservation, but a lot of that's done because, as we talked about, 1 coil per 2 cylinders, et cetera, et cetera. Well, now with a modern standalone programmable computer, instead of running 2 computers, you could run 1 single box. You can take the ignition out and put coil on plug in it. You can add all of these things, that you don't currently have. There's even aftermarket programmable NOx sensor kits. We could adapt NOx sensors onto this motor. So then you can get into running more timing advance and less fuel during more critical parts of the power curve to get sharper response and more torque sooner instead of waiting until 4 grand for the turbo to wake up. You can start bringing it in at 3,500 because you can run more timing and less fuel and get more, you can't probably go quite full 458 because you can't convert to direct injection, but you can get really damn close.
Guys, red line on these things.
75.
And it's still flat plane, right?
Yep.
It's a flat plane 2.9 twin turbo.
It's a body kitted twin turbo 308.
Yeah, basically. It's basically the same block, right?
Yeah.
I think the US models are rated at 471 or 472 horsepower, I think is what they're rated at, Well, I know that the US spec ones with cats, mufflers, the whole bit, straight off the showroom floor, would rear wheel dyno just a little bit over 400. Euro models, because we have a friend with the Euro model, his dynoed 450 stock, bone stock, 450
at the wheels.
So another 30 or 40 horsepower.
And the Euro cars get to run more aggressive camshaft timing than the American cars did. Plus, they don't have the catalytic converters. They get a couple of things in the Euro cars
there's a
that
bunch of things going for it. But then you get rid of a muffler or the cats or whatever, and then the power starts to really pick up. So I would guess that this thing probably makes the same power as a Euro one, 440 wheel, which is, again, for a car that was really designed in '86.
It's wicked.
It's pretty good,
And it doesn't weigh, very much. We think about the Countach over there. That makes similar power, but it weighs several hundred pounds more than this car.
Yeah.
That's about a 4,000 pound car, whereas this is about a 3,000 pound car.
Yeah, 2,900 pounds, I think is what these cars.
Yeah, it's funny because the first time I stood next to F40, the thought going through my mind is, wow, these are tiny. Like it's just a very small car. It
Your
looks
458
well,
is
it's very wide, yeah, but it's just it's
your
it's,
458 is a Cadillac compared to
Oh
this
yeah,
thing.
no, I mean it's a monster compared to it, but it's crazy how small this thing is.